We're going to kick this off now. So, my name's Brian Hunt, president of Hunt Utilities Group. Hunt Utilities Group makes this fine product that drew you all in here today. And I'm co-presenting with Bruce. I'm going to take the first part. What we're going to cover is the various in-floor heating options. We've got homeowners and contractors here. I'm going to cover some of the basics of in-floor heating, some of the options that are available. Contractors probably know most of that. And then we're going to dig into the technical details of how the system works, how to install it, and troubleshoot it. So first of all, why do radiant in-floor heat? If you're here, you guys probably have a pretty good idea in your head why it's so cool. But warm, why is it so warm? So it's got to add quiet to the list. Comfort though is the main thing. It just feels good to have a warm floor. I've never seen anyone who had a warm floor go, I don't need that. I want that warm or hot air blowing around, making noise, pushing dust everywhere. And heat source flexibility. Anything that can heat water can be used to move that water around through the floor. When doing in-floor heat, there's two ways to do it. There's the electric way, where you can actually put electric heating elements under your floor. That generally costs a little more, but it's beyond the scope of what we're talking about today. The electric is generally used for small systems and less economical for whole houses, and we're going to be talking about the hydronics solution, the flow of water through the tubes. And that is more economical for houses, for larger floor surfaces. And it's traditionally achieved, you can see in the diagram here in front of your screen, you've got the boiler, an expansion tank, air release valve, overflow, or pressure release valve. We've got temperature sensors, manifolds, temperature mixing valves, one or more pumps, and of course the tubes in the floor. Our system, you're here because you've heard that it is a much simpler way to do it, and we'll get into that in a little later. But the general idea is you got something to heat the water, you got the mechanics to distribute the water out to the tubes in the floor. When do you use in-floor heat systems? Homes, garages, barns, sidewalks. Don't need to go into this too much. Again, if you're here, you've already got some concept of that. This presentation I often do at a trade show where I'll do an informational session. I'll spend a little bit more time talking about it then. One thing I do want to say is if you're doing driveways, it takes a lot of energy. So it's different than heating the floor inside a nicely insulated house. So how to plan it? It's important, like doing any construction project, to plan it, have a few thought, or have a little guidance to make sure that it goes really well. The loops in the floor is the main thing, the first thing. 300-foot loops are a rough guideline for the maximum that you want to do. If you do 301 feet, the whole thing's going to blow up. Just kidding. No, it's not sensitive that way. You can do 350 feet. Our pumps are particularly suited to be able to do slightly longer loops than 300. But 300 is a really good guideline. If you can try to stick to that or lower, there'll be more water flow. The longer the loop, the more resistance, the slower it flows. And you want as much water to flow through those loops as you can get. You can count on particular heat load for your house. We'll talk about that more. And then each 300-foot loop can deliver 6,000 to 7,500 BTUs. When you're running those loops through the floor, you want one length of that tubing. It's 1/2-inch PEX. You want 1 foot of that through every square foot of floor. So if you've got 1,000 square feet of floor, you're going to have about 1,000 square feet of PEX, plus little ends that stick up coming out of the floor. There's different kinds of floors, obviously, in a house. The in the concrete is the easiest way for this to work. It runs the water easiest through there. You can put it on top of a floor, either embedded in gypcrete, or you can put it in panels with grooves. And we'll be showing you a little more details about each of these. You can also put it underneath a wooden floor. And we'll give you pictures here. In concrete, there's a few considerations. You almost always want insulation under your floor. There's actually a fair amount of heat loss that can happen. There's some alternatives to that. We're doing a building right outside here in our own facility, our own campus here. We're doing a home with no insulation under the floor, and I don't want to talk about that too much, but there are exceptions. Generally, you want the foam, you want the tubes stapled to that foam, or tied to the rebar that you put in the concrete. You run the water temperature through there. It's really efficient how the heat transfer through the tubes into the concrete. So you can run the water at a pretty low temperature, between 80 and 100 degrees, depending on your heat load, and you should do pretty well. Gypcrete over a wooden floor. Gypcrete's a lighter form of concrete. Well, it's not different chemistry, but it's basically a lighter form of concrete you pour over a floor. You need 1.5 inch layer. That means you have to have a extra bottom plate on your wall, so it's kind of nice to plan that in ahead of time. It's a little harder to retrofit, but it can be done. And the tubes may need to be closer together on a gypcrete. Anytime it's a thin slab, the heat doesn't propagate sideways as easily, and so you'd want, I've heard recommendations that the tubes may want to be as close as 6 inches. The trade-off is more tubes, you can run cooler. Fewer tubes, you got to run it a little hotter to be able to get the same amount of heat through the floor. When you're doing the concrete, the foam underneath, we have an option that we saw at a trade show and we're like, oh my gosh, we got to offer this. It's right behind me, one of my favorite show and tell toys. The idea is these little knobs here, they lock the tube right in place. There's no tying, there's no stapling it to the foam. You just kind of walk it and you push it down with your foot, and it locks in there, and then it protects it from, because it's below those knobs, it's protected from the wheelbarrows when they actually deploy the concrete over it. And it protects the tubes from damage that way. It's a pretty cost-effective price of insulation these days. You really aren't paying much extra at all for this labor saving. To get where the tubes come up out of the concrete, we have our HUG Holy Hose Holder. It's a mouthful, but when we saw it, it had lots of holes on it, and it just kind of came out and it stuck. So the Holy Hose Holder that has turnable elbow conduits. You just push the PEX in, pops right up the other side. We've had contractors that have done so many houses before. They got this and they were like, oh my gosh, where was that? Where has this been? There's other products out on the market that'll do the same job. This one we recommend just because it brings all the tubes up right behind the tank in the format, or a nice orderly format that matches what comes out of the back of our hydronics system. For really small installations, if you've only got a couple of loops, it might make more sense just to go with our 1-loop kit, which is just a couple of the elbows and the clamps. For wooden floors, we've got my other show and tell piece is over here. As you can see in the picture, this is called EcoWarm Radiant Panel. It's meant to go on top of a subfloor. It's got the, can you see that? Mm-hmm. Showing it to the camera. Yeah. It's got the tube in it. It's got an aluminum layer over the top. Makes it really easy. Those guys are great to work with. We've talked with them on a few projects. They'll If you send them your footprint, or your blueprint, they'll send you back exactly a plan for what board goes where and what it would cost, and they can ship it right to you. Underfloor with heat spreaders. My cousin was so happy I was helping him put in warm floor in his 100-year-old St. Paul house. And so there's these aluminum plates, stamped and curved. They hold the tube. You put it up on under the floor, and you staple it up. It's easier under new construction. He was doing a big remodel of his house, so he was able to fit that in. Still took a little working around nails that were sticking through the floor. It's a fair amount of labor. It'll burn your elbows or shoulders, but by the time you're working overhead all day, putting those up there. But the result worked. And it's very viable. It's a little especially easier for retrofit applications. One trade-off is you got to get that heat through the floor. There's multiple layers of floor, so you have to run water a lot hotter than you do like in a concrete slab. PEX pipe. There are various types of PEX pipe. For in-floor heat systems, what you are looking for is hydronic type. PEX B is a more flexible kind. There's A, B, and C. You want oxygen barrier type. That has for our system, that's not a requirement. Some places code, that's a requirement for the oxygen barrier, and for some other systems, if you ever have to retrofit in the future, there may be advantages to having that oxygen barrier system in there. And it's only a small price increment over the non-oxygen barrier system. It used to be huge a long time ago. It used to be a big price difference. Now it's just real little. It's still only 30 to 50 cents a linear foot. The rolls typically come in 300 foot, which is very convenient for a 300 foot loop. The 1,000 foot loop, you can either make 333 foot loops or 4 250 foot loops out of that. And don't forget the little ends that stick up, or if you're running it over your overhead in a floor above you, allow for that tail that comes down to our unit. Pressure testing. When you put the PEX in, it's a good idea, well, code requirement in most places to pressure test it. We offer a kit. We can basically rent it to you, but it's not all that expensive to buy it outright. It's part of a system, and you link them. Our system links them all together. Otherwise, you can do one loop at a time, and it's a pretty easy way to make sure that there's no problems in your tubing. The hydronic fluid, the working fluid in there, it's generally, we recommend water if you don't think that there's a big risk of freezing. If there's a significant risk of freezing, then we recommend antifreeze. But we recommend, it's propylene glycol. It's, we get the hydronic rated stuff. We sell the Cryotech 100. There's other brands out there, and it's very stable. It's great for, I think there's another pros and cons here. Yeah, there we go. So water alone, inexpensive. It transfers heat better. The antifreeze has a trade-off that it doesn't transfer heat as well. The cons are with water, of course, it might freeze. The antifreeze, of course, won't freeze. That's its main thing. Everything else about it is harder. It's more expensive. It will need maintenance eventually. It will need to be it's good practice on both the water and the antifreeze to check it, well, every fall before you start the system up, and see if it needs any additives or adjustments. So our system, you remember that slide from the beginning about what's in a system? Ours is taking all the plumbing that is associated with the normal one and replacing it with a tank of water with a handful of submersible pumps in it and a controller. The basic concept is a tank of water, a handful of submersible pumps. One pump feeds the heat sources. Actually, you can have up to 3, but it's illustrated here as 1. In most cases, there's only 1. So one pump pumps the water up to the heat source, returns the warm water into the tank. That warmed water gets pumped out to the floor by each one of those pumps. Each one of those pumps can feed 1 loop or 2 loops with an optional splitter. We'll be talking more about that option in a little bit. And it plugs into the wall. The wall voltage is turned into 12 volts DC, same thing as a car battery. It's low voltage and safe. Get your hands in the water working with an electric pump, you gotta wonder about that, right? So it's safer that way. And we can handle up to 4 thermostats. You'll note there's not a single valve in the whole system. There are lots of flexibility, and just super simple. I'll show you the plumbing system, how to do the plumbing connections in a little bit. First I want to talk about the internal flow concept of it. The warm water gets here, returned on this side of the tank, along with where it mixes with all the return flow from the floor. The light blue or aqua colored arrows represent water coming back from the floor. So that's the coldest water. That's why we're drawing the water for the pump through that, from the coldest water. So it gets the most chance to be heated up. And the warmed water is mixed automatically with the flow. And it's just nice to be able to understand the general concept. Instead of just that one pump, yeah.
So that's just your primary loop right there then?
Yeah, that
Okay.
serves as the primary loop.
Okay.
And in contractor speak, the entire unit is a hydraulic separator.
Okay.
Let's see, where are we? Yeah, we can have multiple, instead of just that one pump, we can put up to 3. There's 3 little spots in that wall to plug in heat source pumps. And so we can integrate not only your primary, like an electric heater, but you could add a propane and do off-peak. You can add a wood boiler. If you are so inclined, you can do a hot water solar panel to help heat your floor. And it's flexible. That can be added later. The advantages are primarily simple installation. The easy, quick connections are a big thing, and we'll talk a little bit more about that. But I'm going to hit it right now. The basic idea is we just take our blue hose, push it down over the PEX, and squeeze this little white clamp on it. There's some better pictures of it, but that's the extent of the plumbing. There are some places you do want to use it, some places you don't. Radiators, we're not the right system for radiators. Because it runs at low pressure, it can cause problems, and because oxygen can get into the system. Those big old cast iron radiators from grandma's house, or some older rentals, those can corrode with oxygen from our system being pumped into it. We can now, I originally had the X here on the pumping the unit, or pumping the water up 2 stories. Now I'm not concerned about that, so we slapped a yes label over that. So the unit will pump water underneath it, up a floor, up and down a floor, or up 2 floors. Now we're going to talk about the heat sources. I mean, it's great to pump water around, but it's nice to make it warm first. So here are some of the options. First of all, how big do you need? That's a matter of what does your house need. There's a simple rule of thumb a lot of HVAC guys use. It's 22 to 25 BTUs per square foot. And for new construction, that's pretty adequate. Older leaky houses that you're retrofitting, you want to do you want to make sure you understand what its heat loads have been. There are way more sophisticated methods than just using a fixed number for every home, because every house is a little bit different. And that would be a manual J calculation. we can help you with that. It's the, yeah, we can guide you to resources. You can find a lot of resources on the web too. The heat through the, so the heat goes from the heater through the tank and out to the floor. Questions are, which heater do you need to deliver enough BTUs, and how do you get those BTUs out to the floor? Out to the floor, this is each loop, a 300-foot loop can do plenty of BTUs to achieve it. The more glycol you add, the more antifreeze, the lower the heat transfer will be. If you're using 50% glycol, which is good for really cold stuff, that's like a minus 20 or 30 rating on it, you will need to bump the pump speed up to medium in order to be able to provide enough BTUs for a typical home. I don't know when that situation would happen, but basically this just says that the pumps and the loops that we have will be very adequate for almost every standard situation. The splitters, so each one of these is one of the loops that comes off the back of or out of the pump. This one comes out, this one is the water returning. When you put a splitter on it, the pump feeds 2 loops, but because of the lower resistance, the water can go through either path and that reduces the resistance. Each loop gets 90% of the same performance. So it's kind of important if you're on a marginal application, you got to pay attention to that extra 10%, that 10% downgrade, but almost never is that really an issue. You can compensate for that by pumping up the speed on the pump 1 step. So 16 loops using 8,100 BTUs per loop. The whole system can do a maximum of about 130,000 BTUs, which for a new house is a lot of capacity. So most people have almost in every case, it's going to be either electric or gas, which is either propane or natural gas. So there's 2 heaters that we have found that work fabulous for this. The on-demand water heaters, they're on-demand water heaters that are space heating rated. We've got a couple sizes in the electric and a couple sizes in the gas. They are inexpensive, really easy to work with. The pros and cons, the electric's a little more compact and easier to install because you don't have to run the exhaust pipe or the gas line to it. The gas is high capacity, a lot of BTUs. With our system, you can't get the rated BTUs out of them, but you can get a lot. So here's an example of the electric one. This is what an installation actually looks like on the wall. You run the tube that comes out of the pump up to it and clamp that on. You've run the wires into the side of it. We've got the 12 kW and 18 kW size, which are 40 and 60,000 BTUs. The gas on-demand water heater, they're 120,000 BTU ratings. They are pretty effective little units that way. What else I need to say about those that we won't cover a little bit later. This table is pretty important. It's for the gas and electric, we get all the BTUs out of it when we're using antifreeze. But as I mentioned earlier, the antifreeze doesn't transfer the heat as well. The gas water heaters have to be derated. Like we don't get the 120,000 BTUs out of them. We get about 75,000 BTUs out of them. The larger one, we can get up to 100,000 BTUs on the higher temperature setting, but that one we don't recommend with antifreeze. So going dual fuel is an option. I really expected this option when we realized that it would happen, it would work. I really expected it to be a lot more popular than people have actually chosen to install. The good news is if they change their mind, they can come back later and add it. Oops, wrong button. Hey, come on, there we go. Yeah, so we can do up to 3 heat sources. This illustrates that. For other things, you can use the other kinds of heat sources, whatever it is that's heating water. If you want to pull your truck up there and run water through the radiator, you could do that. I don't know why you would, but you could. So here's an example system. This walks through how we would pick which heater would help you best. For 2,100 square foot home, 1,200 square feet on the lower level, in concrete, 900 square feet on the main level. So 1,200 square feet, divide that by 300 foot loops, that gives you 4 loops there. You can put those 4 loops with 2 pumps and 2 splitters. In the up above the 300 square feet on the main level, that's 3 more loops. So it's a total of 7 loops. 2 sets of splitters for the ones in the concrete. We can now do the one up above. For a while we weren't sure you could use splitters up above, but now we're confident in that. We've tested it and we're pretty happy with it. So that can be done with another 2 pumps. Assuming the standard 22 BTUs per square foot, you're going to need 46,000 BTUs per hour for 2,100 square feet. And converting that to electric, that's 13.5 kW, so we would sell you a 14 kW, well 18 is the one we're settled on now. We can get the 14 off that because we're not really selling that unit. It's interesting, the difference between a 12 and an 18 is not a lot of money. So the product selector, to help you guys walk through that, or anyone walk through it, we have what we call a product selector on the website. You can enter all the parameters, the square feet, what kind of heat source you want, whether or not you want antifreeze, and it'll recommend the configuration, complete with an illustration, what you want to do there. I don't think we need the duck on this slide anymore. The duck is our tech support mascot, but this one has this one doesn't have the glasses and the laptop like the new one we hired. On the website there's also the FAQ sheet, the full manual, quick start guides, videos. We're trying to make it as totally easy to get the help that you need and the understanding ahead of time. If there's any code questions, we can work with a code inspector. They look a little, or they may question the plumbing connection. In that case, we have a report to offer them. In Minnesota and almost every state, there's a way of doing an alternative solution, where the inspector says, okay, I accept it to do this job. And so we have a language that, or a report that speaks inspectorese. The silicone hose that we use is rated for 350 degrees Fahrenheit. We only need 170 max on our system. It's rated for 80 PSI. We're only pushing it at 18 PSI max. And usually it's running about 5 PSI or less. So it's way overkill for the job. The little pump, we often get questions about this. This is the submersible pump. It's a high-tech little unit with fancy polymers, graphite bearings, stainless steel shafts, and super smart little electronic control package that we talk to for it that protects it from, or protects itself from damage, and allows variable speed settings. So it'll run for 30,000 hours, which is at least 15 years, depending on on how you run your system. The it allows us to run, it's variable speed, so we get 4 speeds out of it. And the flow, we have the flow ratings for professionals who care. We have the pump curves. This is how it compares to other pumps in the industry. And if you want more details about that, feel free to reach out to me. All right, we're going to talk about what it takes to set it up and install it now.
Hello, I'm Bruce Diamond, and I'll walk you through the initial startup procedure. So as Ryan explained, our system's all about ease and simplicity and ease of installation. It's installed with basic tools. Everything to install it is in this toolkit, and we'll walk through that next. There's everything you need to do to get ready is on the checklist. You have the heat source installed, the PEX is installed. You've got some tools in front of you, a splitter, cutter, and a pair of pliers. You have your mix of glycol or water ready and available. An outlet near the unit, and you have your thermostats installed. So those are some of the items that you need to think about before you do the install. When you get the unit, the first step is you remove it from the box and look inside the unit to make sure there's no debris. Remove all the packing equipment, and then you check to make sure the pumps are just seated properly. Just a quick visual inspection. And then you place the system in front of the PEX on the floor, typically. And the next step is you hook up, there's an optional drain port on the back of the unit. And we can show you that maybe a little bit later, but it's just here near the back of the system. You just connect that to the drain, connect it to your flow. And the next step is to connect the source and return hoses to the PEX pipes. So the hoses come out of the unit, and then they just connect up to the PEX coming out of the floor. You have flow in and a return for each of the PEX lines. And you trim the hoses, you know, just so there's just enough to keep it into the system, so when you get it closed up, you get a nice clean look. And this is just an illustration of doing the clamping. It's a simple clamp to the PEX of the silicone hose. You can just use a simple pair of pliers, and so you connect your source and return hoses. And then after you have your hoses all connected up on the back, connect up the heat source. And for that, there's 2 hoses, typically one on each side of the unit, so you can connect the into the water heater for the cold and the return to the unit for the hot. And the 3 heat source pumps are on this side of the tank. It's just, the illustration shows a connection for the gas is on the bottom, the electric's on the top. For the electric, you may need to plan to make sure you don't mount it too high above the unit, typically about a foot above the tank. The next step is to connect the thermostat wires. You route the thermostat wire through one of the holes in the back of the unit and bring it in. And then you pull out the connector. There's a connector here for connecting up the thermostat wire. You strip your wire and just connect it up. There's 4 different connections for thermostats, 1 through 4. You have a power and a return connection for each one. There's some additional steps for connecting up a smart thermostat. JP43 must be removed. That's the jumper just above the connector. In this case, we've removed it for the smart thermostat on this setup.
The reason is a smart thermostat requires, as you see here, sorry.
Yeah, the 24-volt supply.
Didn't realize the slide was next, so go ahead.
So wiring a smart thermostat, as Ryan was pointing out, we need 24 volts. So you have to have that transformer ready and available when you're doing this install. There's a nice picture here that shows how it would be hooked up with a smart thermostat and a wiring connection with the transformer. Here's even a better illustration. So it shows where the wall outlet is connected up in the power connections. Wiring an optional alarm board. So our unit typically comes with an alarm board, and you can use that to wire to a smart thermostat. And if you're doing that, there's a J2 connector on the smart thermostat, or the alarm board for the smart thermostat. And then the alarm board also has a jumper on it for setting the volume. So once you have everything wired up, the next step is to fill the tank. And when you plan, you need about 1 gallon for every 100 feet of PEX, and then plus the system requires about 10 gallons. So typical systems might have 16 to 20 gallons of water or glycol mixed you need to plan out. And the next step would be power up the unit. And we've already kind of been playing with this one, but the power switch is here on the right side. You simply power it up, and when you're doing this, you plug in the tank to make sure it's plugged in, and I believe also you pull the thermostat connector from the board when you're doing the purging, so you're not getting any other signals coming into the system while you're setting it up. So to purge, you take one of the jumpers. It's just a simple little black jumper, and you go to each pump and you just jumper the purge, and you hear a little gurgling sound for a little while, and then once that sound goes away, you purge all the air out of the line. And you
On
just do
a
that.
300-foot loop, that'll take about a minute or two.
Yeah. And as you,
Quick, actually.
Yeah, I've heard
it's
that.
quite quick.
Compared to other systems, getting the air out of it can take quite a while.
So you
Yeah,
got
I mean,
one,
usually takes a couple minutes or so, but
1 to 2 minutes, and as it goes down, you can easily add more. Just pour it into the system, and you just keep doing that.
Yeah, we can just put
That
it
one's
right
nice
into
and
the
quiet.
tank.
Go to the next one, might be noisy. Simple step.
I don't know if the people online can hear that gurgle that happened.
But it's a simple step, takes about 1 to 2 minutes. Next step, or you set up the system settings. You set up your heat source. Typically, you set the setting on the heat source for 120 to 140 degrees Fahrenheit. If you're using the electric, it usually comes set up for 120 degrees. Some people like to use 110. And then the next step is you plug in your thermostat connector, make sure your thermostats are connected to your board. And you assign the thermostats for each of the zones. So in this particular setup, we have 2 thermostats, and you can go to each of the pumps and set up which thermostat you want it to operate from. So we have some here that are operating on thermostat from zone 1, and then we have some that are operating on either thermostat. And you also can set the pump speeds. The system will come with the pumps all set at low, but you can change it so you can have a pump run a little bit faster if you want to try to balance out some of the heat. And those are also right there in the bottom. The max speed, you can get up to about 5 gallons per minute, but with a 300-foot loop, it's about a gallon and a half to 1.8. Next step is you adjust your thermostats. Make sure you have everything set for the nice temperature in your house. I think we'll do that. One of them calling for heat. So another thing to note here is that zone 4 is set up as a low priority. So if you have a zone in your house that you don't want to, heat all the time, so if the house is calling for heat, you have the garage calling for heat, it heats the house first. so you can set up the garage on a lower priority. To do that, it's a lower priority if JP 42 is in, and that's near the top over here. So we're using that for zone 4. And then the next step is to do a final check, and I'm doing that right now. You have the thermostats calling for heat, and you check to make sure the proper pump lights come on and zone lights come on that you expect. And at this point, you also check to make sure that there's enough glycol in the system, and there's a water level sensor in the center bottom of the tank that you can check for that. Any quick questions? Any questions?
At that point, the system's working.
And there's just a couple of things where you just put the lid back on and cover it up. Turn this back down to somewhat normal. The neat thing that about it, one of the neatest things is that it provides a nice clean install look when you get done. There's, not a mess on your wall, and it looks like any other normal appliance in your house, like your furnace or your dishwasher. So troubleshoot and maintenance. So there's a bunch of diagnostic lights on the top. Each of the pumps has a light, and each of the thermostats. So we'll walk through that really quick. And there's a water level sensor and a water level light on the unit as well. So the power light is here, so this will illuminate when there's power, should typically be on. So if there's something wrong with your power supply, you can check that to make sure your power light's coming on. There's also a 6-volt overload light. Typically, if this is out or it's unplugged, it'll mean that you have a bad water level sensor. Each of the pumps have different lights. When it's off, it'll be glowing a dull green. As it goes on, it'll get a brighter green, like that. If it's on max or high, it'll glow nice and bright. We also have a low water sensor on the unit. So if the unit gets low on water, and I think what I'll do is just demonstrate that. Pull that out. So if the unit gets low on water, it'll protect itself, shut down, and then give you an audible alarm. And then if you have it hooked up to a smart thermostat, you get a message on your phone that you have a heat pump or heat problem. It's annoying, so we'll
And that was on purpose.
I'm sure you can hear that. There's also a max tank temp setting. The tank can be set up so it runs the heater at particular speeds to warm the tank. So if it's set at the lowest speed setting, it'll try to keep the tank closer to 90 degrees. At the high speed setting, it'll try to keep it to a tank temp of about 150, 140 degrees. There's different settings. Typically with this setting, you want to keep it someplace in the middle for the max tank temp to get the best performance. But it gives you a way to adjust the speed of the pump as it comes into the tank.
If you're doing one of those underfloor installations, you'll want it way up high.
Concrete on the lower end. Thermostat zone lights. So each thermostat has a zone light, 1, 2, 3, 4. So when it calls for heat, that light will come on. We talked about the low priority jumper a little bit already, but there's a jumper here, so if this is in, then zone 4 will be at a lower priority. Each of the pumps has a fuse. So if it blows a fuse, you'll get a red light, and then also it'll put out the audible alarm.
In all of our experience, we've never had a fuse blow. We just had to put them on for regulatory purposes.
And zone, the heat source pump will, if that fuse goes, it will also shut down the whole system. That is the main power fuse.
Yep, that's the one on the end. So let's, a little bit on the fuses, checking the power. There's, the power supply is here on the end. If you have a problem with the power supply, typically you can check the cord. The power cord is in the back. Usually if there's a problem, you just need to push that in, and back today when we were setting it up, there was, the power cord wasn't plugged in all the way, so now it is. Any questions, comments?